I'm Nate Zamarowski. My unit is Floaters and Sinkers. Today's topic is what floats your boat? So kids, how does a submarine work? This is the point I wait. I let the kids answer and figure out different situations. That's right, it's buoyancy. Okay, good. In order to better understand how a submarine works, we need to know the difference between incompressible and compressible gases. Fluids, excuse me. Now, is air a solid, liquid, or gas, class? Gases students should answer at this point. Okay, good. Gas is a fluid. Here's an example of gas. We've seen these before in class. We have our normal cube. We have the gas particles trapped inside. They're traveling every which direction, bouncing off everything. So remember that in a gas, the molecules are bouncing around and hitting each other in the sides of the container, keeping the shape of the container if it's a flexible container. Okay, so what about water? Is it a solid, liquid, or gas? At this point, again, I let the kids talk. Different turns, taking the time, raising your hands, answering different situations. They should come up with, it could be any type of them. You have ice, liquid water, and vapor. Okay, so normally it's a liquid. Are liquids fluids? Yes. Here we come to our next slide. So right here on the right we have water, which is a liquid, and on the left we have our air, which is a gas. What would happen if we pushed down on the air? I just took a lid here and compressed all the way down. Can you compress it down? Again, I wait for the students to answer. They should answer yes, because we've done experiments in the past before with different balloons, so they can compress them down a bit and stretches and so forth. Yes, air is compressible. That is very good. So in other words, for squishing something down is compress. It sounds like press. Look at the second part. When I press down on something, you're squashing it. Since air can be compressed, it's called a compressible fluid. Next, we're going to discuss water. If we push water down, does it get squished, and why? Since the water molecules in this box are so jammed together and pushed next to each other, when you push down, there's really not much room. You can't squish them. They're already touching. They can't get any closer. But in the gas, since they're not touching, you can push them closer where they're going to touch. You're going to increase pressure. Okay, since the water can't be compressed, it's called an incompressible fluid. Since it's on the opposite of compressible fluid. Lots of times we use the prefix in to mean not. We've seen this before. You've also seen it in English class. So remember for our lab activity that water is incompressible fluid, but air is a compressible fluid. Now, what's for the formula for density? Again, we talked about this before. I let the kids talk around and raise their hands. We discussed what the formula for density is. Density equals mass over volume, or in short, D equals M over V. Okay, so what does it mean when something is more dense? Like if I dropped a bowling ball in a pool, or a beach ball in a pool, which one's going to float? Again, I let the kids discuss. Some of them will write down. Depends on each class and each student, whether they're writing it down or discussing. Guess I should go back to the answer. Obviously, a bowling ball will sink while a beach ball will float. Okay, so what fluid are we in now? What is in the room all around us? This one usually takes a while discussion. Most kids don't realize, they'll say air, but they don't realize that it's a gas around us and that it's considered a fluid. So is our density greater or less than air? How do we know? Again, I had the students explain, had the student answer, had them discuss among each other. I really like to get their point of view because they understand what they're saying more than what I'm saying a lot of times in describing it. I'll do it more technical and they'll say it in more terms that they can understand. What if a balloon is filled with helium? Is its density lower or higher than air? Obviously it is. I'd let the kids answer and we continue through there. I usually have balloons in the corner that I can do this for, and then I'll suck the helium in. We'll talk jokingly funny and stuff like that. Okay, so diver setup. First, I'm going to need you guys to group up. This time the kids are getting the groups. They know the groups. Check to make sure the group has a direction sheet. Each group should have one direction sheet, and each person should have their own lab sheet. The lab sheet's your responsibility. Please write your name on it, the date, and your students' names on it in your group. I'll give you time for that. Check to make sure you have all the supplies listed on your experiment sheet. Next is your lab sheet. Please take time to answer the questions on the lab sheet as a group. Each student is responsible for writing down the information on their own paper. Hand it in at the end of class. If it's not completed, it is considered homework due Monday. I usually do this on Fridays, just so people know. There's about 6 questions the kids have to answer on pre-thoughts. You'll receive the sheets on what the experiment's going to do and what they think it's going to do before they actually perform it, to get a little insight of what their knowledge and how they can apply it. Next is I'm going to go over the instructions. I perform it and then let the kids go around in their groups and perform it themselves. So, first off, fill this up with water. I already have mine filled up with water, students, to save time. Your water bottles and your funnels are on your desks. Please wipe up any mess when done filling. You're going to want to fill it all the way to the top of the bottle, so there's barely any left. Just about like a 1/4 inch to a 1/2 inch of space. Make the Cartesian diver. You're going to take your bendy straw, stretch it, bend it. You can measure 4.5 centimeters. The easiest thing I found most people to do is just take that right there, and you cut it right where they meet. That way you have an even diver. Then you're going to take one of these paper clips. Step 3, take the paper clip, bend the big loop, and so it fits in both. That works, but you can also do this. Make it V. Pull the middle out so it V's. Then you got to tuck this in each one of the ends. So you got it like that. Put it in, it floats. It needs a little weight added to it for it to sink in a little bit more. So what we're going to do, the next step is take the straw paper clip out, hook another paper clip to it. The directions tell you to do this. It's really easy if you just take this and slide them on, and then test it. Nope. Pull it out again. You're going to do this. It's a little bit of trial and error. Since all the paper clips weigh differently and are made of different material, sometimes you got to figure out how many you need. Oh, looks like I need one more. And I used one too many. So when you use one too many of the large ones, take one off and use a smaller one. This is why you guys will have different types of them in your thing. We'll see if that works. At this point, you got to put the cap back on. Make sure it's tight so you don't squeeze the water all over yourself. Then you got to pick it up and give it a real big squeeze, and something should happen. At this point, I now want you guys to group together. I'll be walking around the room with the assistants. We'll be helping if there are any questions you needed. Homework this Monday at the end of class. Go home and show this to someone else. Write down how they think it works, and then I want you to explain what you learned today in class and why it works. Thank you. Have a nice day.